Alright everyone, in this video we're going to take a look at the multi-layer Starfield class. And as we had mentioned in the last video, the goal with this Starfield generator is to make a pseudo 3D effect for the Starfield. That is, we're going to have stars that are in the background to the bright stars that are a little bit darker and a little bit slower. This gives the impression that they are further away, and that gives the pseudo 3D effect. So what we want to do here is we want to make a class that is going to manage an array of starfields.
I mean, we could right now with what we have just go into game and create 3 different starfields and set their speeds differently, set their colors differently, and let it go.
Sure, that would work just fine. The only thing I don't like about doing that is we would have a lot of code dealing with multiple starfields just laying around in game unnecessarily.
Exactly.
If we instead encapsulate the entire idea into its own class, it makes the idea much more portable and easy to use.
I agree.
So, this video is going to cover, of course, the multi-layer Starfield class, and that class is going to have pretty much 2 jobs. Its job is going to first make multiple starfields. Its second job is going to be to manage multiple starfields. And its constructor and draw method are in many ways going to look similar, especially to the outside of the class, to an individual starfield. The reason being is that the constructor and the draw method are going to primarily pass through all of the parameters that describe a starfield. It's actually going to handle the, you could say, the background effect of making the stars darker and slower internally. So it's going to require no external help. The only thing given to the multi-layer starfield is how many layers deep you would like your effect to be.
Gotcha.
So with that, I guess we can go ahead and just jump right in and get started.
Sounds good.
So here we are in our project, and to the project I'm going to add a new class. So our new item is going to be called the multi-layer starfield. Multi-layer starfield as our class. We'll do a little bit of cleanup here, make sure we remove the subnamespace. And I would also like the same using statements that we had in the Starfield class. That is the usings for XNA.framework and graphics. So to save time, I'll simply steal both of those, and I'll paste those over collections and text. Alright. The next thing I'd like to look at inside of the multi-layer starfield is its 2 fields. It's going to have one field that simply describes the background fade, I guess you could say strength or amount, and the other field is going to be the array of starfields that are used to manage starfields. So our first field, private, I'm going to make this value a float because I'm going to use it kind of as I'm trying to think of the right word. It's the opposite of an incrementing effect. I guess you could say a decay effect.
Okay.
Yeah, and I knew that was coming too.
Sorry, I just couldn't help it.
But all right, this field is going to be called background fade, and background fade will initialize right off the bat to the value of 0.5, not 0.f, but 0.5.
Okay.
Now, of course, the other field is going to be an array of starfields. We'll also make this a private field. Its type will be of starfield array called starfields. Alright, that takes care of fields, so I'll skeleton the methods first, though I believe I'm going to turn right around immediately and implement them. So to get the 2 methods in place, well, really it's a constructor and a method. The constructor is going to be a public constructor. So a public multi-layer starfield. And we want to make a nice set of parameters. The reason I'm going to add quite a few parameters, and the reason being is I want to pass all of these through to the starfield. So that means I could save time here at the moment. I could leave the parameter list empty for the moment. And since we know a multi-layer starfield needs to, in fact, describe starfields, I could actually move over to the starfield class and copy its parameters from its constructor, because all of those things will be required in the creation of individual starfields. So we could drop all of these in here, and now we're several minutes ahead of ourselves. But we will, in fact, need all of these, though we are going to add one thing to this. Right now we have all of the parameters that describe one starfield, but we need one more piece of information, that is, how many starfields to create for this specific multi-layer starfield. And I'm going to call that parameter layer count. We'll make it an integer parameter, layer count. And let's see, layer count actually gives us the ability to go ahead and kick off the constructor, though. Actually, let me go back a few words here and say that I'm going to skeleton the next method in.
Okay.
As I was starting this, I was saying that I'm going to skeleton in, so I'm going to stay on course and skeleton everything.
Gotcha.
And that means that we're going to look at the draw method. So we'll have a public void draw method, and we'll do an even better one for this one. For the skeleton, let's steal some more stuff from Starfield. Let's take Starfield's draw method, the whole signature, paste it in directly, and block it in. And we're ready to go, because the multi-layer Starfield should draw, at least externally, should draw just like a normal Starfield. Alright, that takes care of the very simple skeleton, so we can immediately turn right back around and implement these things. First is the constructor. What do we need to do to manage Starfields? The first thing we'll do is we'll initialize the Starfields array. So we could say this dot Starfields is equal to a new Starfields array with the number of elements being layer count. Then the next thing we can do is we can build a for loop around layer count. So we build however many Starfields are required. So we'll make a for loop. We'll loop up until the layer count value. Now inside of this for loop is where we create individual Starfields. That means we look at the Starfields array, sub I, and we set that to a new instance of Starfield. Now of course Starfield takes in quite a few parameters, and those are all given by the constructor to the multi-layer Starfield. That means we simply pass through the graphics device, the width, the height, the density, the speed, and the color. All of those get passed along to the Starfield's constructor. And that's, really we could leave it there and we would in fact have multiple Starfields. The problem is all of them would have the same speed and the same the same value, the same brightness.
Exactly, so it would just look like a whole bunch more stars.
Exactly. So what we would like to do is instead, for every Starfield created, take and apply an amount of decay to both speed and color. And that decay amount will be given by background fade. So we'll look at the given speed parameter, and we'll multiply that by the background fade value. So every time we create a Starfield, we lower that by half of its current value. And we would like to do the same thing to color. We'll have the color become an amount darker based on background fade. But to do that, we're actually going to need to look at the individual red, green, and blue and assemble that into a new color. Right. So that, let's say we had the color red taken in. We want to make sure that color stays red. So we adjust each of the components individually and maintain the overall color. So that means color is going to need to be set to a new color, and we'll specify red, green, and blue components. For the red component, we start with the current color red value, and then we multiply that value by the background fade. Now, of course, that calculation is going to need to be cast over to byte to make sure that it can be stored in the color. And then we need to do that several times. Actually, let me put the cast in proper parentheses over the operation. Now, for each of these components for the color, I'm going to drop down to new lines just so that everything will fit on screen. And I'm going to begin by copying one of them and pasting that on the following line, and maybe space it out a little bit. And possibly do that again. As a matter of fact, even better, we'll copy the existing one, paste that, and there we go, 3 components. That gives us the ability to do red, green, and blue separately, but all based on background fade. Then we can end off the call to new color and end off the statement. So that should handle fading the background color closer and closer to black. And with that, I think that takes care of the constructor.
It does.
Now we just need to take a look at draw, where draw must manage multiple Starfields and in turn call each of their individual draw methods. So let's make a for loop to iterate through all Starfields. So we'll use the same index-based variable, but this time we're going to loop through the Starfield arrays, so Starfield's length, since that's now the value telling us how many Starfields we have. Now inside of that, we just look at each individual Starfield and tell it to draw. So Starfields sub I dot draw. Draw needs to be given sprite batch, game time, width, and height. All of those are available as parameters to the multi-layer Starfield's draw, so we just go parameter by parameter, feed in things like the sprite batch, the game time, the width, and the height. And that finishes off our call to draw. Now I'm going to build, make sure that I don't have any glaring syntax errors in the multi-layer Starfield.
Now we are aware of the fact that there is a bit of a problem. just want to point that out
yes,
right now.
Yes, just ahead of time, we are going to have a draw issue here because of the way our for loop is running.
That's right.
We're advancing forward, starting with the very first created star field. That means the brightest. Mm-hmm. The brightest star field gets drawn first. Then the next field is going to be a little bit darker, and it's going to get drawn second. And being drawn second means it's going to draw on top of the first field.
That's right.
So that means the so-called background fields are actually being drawn in the foreground, right, which will make the effect look wrong. But I did want to point that out. And I actually want to show the effect in practice, even if I have to up the number of stars to show it. Because with the star field being as sparse as it is, it can actually slip by unnoticed. And you just get this very faint feeling of something being wrong, and you can't quite pinpoint it.
Right.
So, yeah, it's good to point out. We will be coming back to that to make sure we address the order in which we draw the star fields. But in order to test anything, we need to get this multi-layer star field put into play back in the game. And to do that is maybe a little bit easier than you might think. It also highlights the reason why it was useful to make this as a class, because now to use this, all we really have to do is change the type starfield to the type multi-layer starfield. Before I do, though, I will jot down one more field inside of the game class, and that is the field that will describe how many layers deep our multi-layer starfield should be.
Okay.
It's going to be an integer field called starfield layer count. And we'll set that to a value of 3. Alright, now looking at Starfield. The Starfield field still makes sense to have the name set to Starfield, but the type here is going to be a multi-layer Starfield. Now in the constructor, of course, we need to make a new instance of multi-layer Starfield. Multi-layer Starfield, if we bring up the parameter list, I'm going to drop the cursor down to the very last parameter, to Control-K, Control-P, bring up the parameter list, and we can see that after color we're expecting one more parameter, layer count, which makes sense from the constructor we'd built in multi-layer Starfield. So I'll add in one more field we feed to this constructor, and that will be the Starfield layer count.
Yeah, upper cover.
I was already forgetting what I had named that field.
Gotcha.
But that extra field now fills out the constructor for a multi-layer star field. And as far as game is concerned, that's it. We build, there's no errors, we run, and look at that. Now, depending on, I guess, the brightness of your own monitor, you may or may not see the stars in the background, but rest assured that when you put this together, that we are seeing stars in the background that are darker and slower. So we have that nice pseudo 3D feel because it looks like there's stars.
You said
deeper.
In the background.
Well, we still haven't addressed the
That's
draw
right.
But like I said, it's so subtle that even I haven't noticed it yet.
Yep, it's very subtle.
So what would happen if we had an extraordinary number of stars? Maybe 100 times as many stars. Wow, we get this very kind of odd shimmering effect.
Mm-hmm.
And the reason we're getting the shimmering effect is because all of the darker background stars are overdrawing the brighter foreground ones.
Right.
And why is this? Well, if we go to multi-layer starfield and look at this really closely, we draw forward starting at element 0, so starfield number 0, or the first one. We go ahead and lay that down on the screen. Remember, 0 is going to be the brightest one. After that, we come over with starfield sub I, the next one, the darker one. We draw that on top of the brighter one, which is the wrong order. And this can be fixed by simply reversing the for loop. That means I could have defined this as a for reverse loop, and then use the same values. Starfields.length -1, going until we reach 0, and then that makes our loop. Though this template has dropped a new set of brackets, so just move our call back into those new brackets, erase the orphan brackets, and there we go. Now if I run, despite the amount of noise on screen, it's still smooth. We see a smooth progression of noise pixels and with nothing overdrawing.
It looks right. I'm meaning that it looks like we've got this bright stuff here at the front, and then you can see kind of through it and behind, and it looks further away and then further away.
And it still has a multi-layer feel, which is the whole goal of the system.
Exactly.
So now I've got the draw working perfectly. Everything looks correct. There's no shimmering effect because darker pixels are overdrawing brighter pixels. And I'll go ahead and set this back to 0.002 for the original desired starfield effect.
Okay, very good.
One other thing I want to tweak about the stars themselves is I kind of want to give them a bluish tint. Now just getting into some of the, I guess I could say the nitpicky tweaking, but of course we're getting ready to do a space fighter-like game, and I would rather have bluish colored stars.
Sure.
So we'll set the starfield color equal to a new color, so I can feed in an individual red, green, and blue value. For red I'll give 200, for green I'll give 200, and for blue I'll give 255. So you can say a very, very light blue. And that gives a nice just something other than black and white, which actually, because of the way the white pixels were darkened, it gave kind of a dirty feel to it.
Gotcha.
Setting these to blue gives a nice, crisp, bright feel.
Very nice.
But, I mean, with that, I think that's everything I wanted to cover in this video. Again, using our old Starfield effect.
I want to spend just a minute and talk about resolution scaling.
Oh, that's a good point. Yeah,
just to throw a little bonus their way.
Yeah, just a little bonus would be, we had mentioned this all the way back in the first Starfield video. We had said we're setting these values. They're about a third of the overall screen width and height. But how does that really apply to screen resolution? What would happen if we changed our screen resolution to 320 by 240? Well, we would get stars that are much smaller. And if we would rather have these stars stay more of an absolute size, we could base our Starfield's resolution off of the screen resolution. So here we could do that with field initializers by taking, resolution X, we could divide screen width by 3. We could divide screen height by 3. And if you remember, if we were still using 800 by 600, that would give us about 260 something by about 200. But here we have 320 by 240, which is, of course, going to be a smaller Starfield. A smaller Starfield scaled up again gives us those original roughly 3-pixel stars across a smaller screen. Or we could do something like make a much larger screen, a resolution of 1024 by 768. Now the entire screen is filled with stars, but the stars seem to hold an absolute size depending on the screen resolution. All we vary is the number of stars that we actually draw. So again, just a small thing to point out as a bonus. If you would rather have your Starfield auto-adapt to the size of the screen, you can do that by simply making sure that your Starfield resolution is 1/3 of the screen resolution. And of course, that 1/3 is also up to you. You can make the stars larger or smaller by making this resolution higher or lower.
Right. All right, so with that, I think that's pretty much everything that we had in mind to cover here in the XNA Xtreme class. So we've introduced how to go about generating a procedural texture, in this particular case, a Starfield texture, how to create that texture on the fly. It's actually quite simple. And then how we could set it up in such a way that it appears to be continuously scrolling forever. And then going that extra step and showing you how we could turn it into what appeared to be a 3D, kind of a pseudo 3D Starfield.
So I'm going to call the Starfield effect accomplished.
Okay, and with that, that is going to wrap up this video. Thanks a lot.